A very good day to the lecturer. We are from group 7 and we are going to present question 4, question 7 and also question 11. So let's see question 4. The 800 kg motorbike travels with a constant speed of 80 km per hour up the hill. Determine the normal force the surface exerts on its wheels when it reaches point A. Neglect its size. So here we can see this distance 100 meter, the distance which is 100 meter, and also there's a function here y square equals to 2x, and this distance is equals to x. So from the diagram here, the normal force is going upward and the weight is going downward, and since the slope here, there's a small angle which is theta. Okay, so first I written down all the values that is given. M equals to 800 kg, the velocity is equals to 80 km per hour, and we have to convert this into meter per second, which will give us 22.22 meter per second, and we have to differentiate this velocity. So if we differentiate this velocity, it will be also equivalent to the tangential acceleration, and the value will be 0 meter per second square. And we also need to find the normal acceleration. So the normal acceleration formula will be v square over rho. So for this question, we need the formula of radius of curvature to find the answer. So the rho is equals to 1 plus dy over dx square in bracket 3 over 2 over d square y over dx square. So this is the first step here, and the second step, we have to find the derivative of this function here. So we need to find the first derivative and also the second derivative here. So the first derivative will give this value and the second derivative will give this value. So after we find these derivatives, we need to substitute the value of x, which is 100 meter, in the equation here. Okay, so if we substitute in the first derivative, we will get 0.0707, and also if we substitute in the 100 in the second derivative, we will get a very small value which is 0.000354. Okay, since the first derivative, it is a slope, we can find the theta value. So the theta value, we will use tangent theta equals to 0.0707, and the theta value will be 4.044 degree. So after we find this, we also can find the rho value. So we have to substitute all the values, and the rho will be 2846.065 meter. So this is the second step, and for the third step, we need to find the normal force. So to find the normal force here, we know that this n is going upward and this weight is going downward. So the sum of normal force will be this, which is negative n, since it's going upward, and plus mg cos theta. So this mg cos theta is equals to the weight. So we use we use cos theta because we need to find this distance here. Sorry, find this w here. So that's why we use mg cos theta. So after we after we write down this formula, and we can find the normal force here, but before that we also need to uh, change the a value, the acceleration value, into v square over rho. So after we do that, we can find the normal force, and it will give the answer 7.69 Newton. So this is the answer. Okay, so for the question number 7, it says that the skier starts from rest at A. So rest is equals to 0 and travels down the ramp if friction and air resistance can be neglected. Determine his speed Vb when he reaches B. Also find the distance S to where he strikes the ground at C if he makes the jump traveling horizontally at B. Neglect the skier's size. He has a mass of 70 kg. Okay, so this question they are asking to find the velocity at point B and also the distance of S here. So there are two things we have to consider here. First, we have to find the velocity of point B and also the distance of point S. So first of all, for this question we are going to use energy equation, which is potential energy of A plus kinetic energy of point A equals to potential energy of point B plus kinetic energy of point B. So the potential energy at point A is mgh, and the kinetic energy at point A is 0 because the skier starts from rest, which is from the start, so it's 0, and equals to the potential energy of B is also 0 because the skier is in the motion, so there's no any potential energy there, and plus the kinetic energy of B will be 1 over 2 mv square. So after we write down this equation, we have to substitute all the formula, all the values given in this equation. So after we do that, we can get the value of velocity at point B, so which is 30.04 meter per second. So we have found the answer for VB. And secondly, we need to find the distance of S. To find the distance of S, firstly we need to find the coordinate at point B and also coordinate at point C. So the coordinate at point B is x equals to 0 and y equals to 0. And here at point C here, there's an angle given which is 30 degree here. So we know that if the angle is 30 degree here, it will be same here also. So we can easily find the coordinate at point C. So the coordinate at point C for x is s cos 30. Okay, and for the y is negative in bracket 4 plus s sine 30. Okay, why we need to plus 4 here? It is because first we have find this distance here, which is s sine 30, but the distance we want is from B to C, so we need to plus 4 because there's 4 here. And why it's negative? Because it's going downward, so that's the reason is negative in bracket 4 plus s sine 30. So after we find both coordinates at point B and also point C, we need to use the projectile motion equation to to further our solution. So this is the horizontal equation, which is x equals to x naught plus vbxt plus 1 over 2 1 over 2 ax t square. So we need to substitute all the values in this equation. So x will be s cos 30 equals to x naught will be 0 and vbxt will be 30.04t and 1 over 2 ax t square will be 0 because there's no any acceleration in the horizontal, so it will be 0. So after we write down this equation here, we can find the t value, which is 0.0288s. So after we do this, we can move on to the vertical equation, which is y equals to y naught plus vby plus 1 over 2 ay t square. So we need to substitute all the values in this equation here. So for y, the value will be negative in bracket 4 plus s sine 30 equals to y naught is 0 and vby is 0 also, plus 1 over 2 in bracket negative 9.81 t square, y negative because it's going downward. Okay, so after we write down this formula, we need to also substitute the value of t inside this equation. So the t value is the previous is from the previous equation, so t is equals to 0.0288s. So after we substitute the t value in this equation, we will get a quadratic equation where we can find the s value. So when this quadratic equation here, there will be two values of s. So the first value is 130.45 meter and also negative 7.54 meter. So obviously here we know that the negative value here, which is the negative 7.54 meter, is invalid, and we consider the S1 equals to 130.45 meter as our answer. So thus VB will be 30.04 meter per second and the distance of S will be 130.45 meter here. And question 11 will be presented by Limgaro. Thank you.